Okay, so today we'll start a new section for the class. Okay, so this here we'll start exam 2. Okay. Before we get started, I put a phrase up here. Anybody know what language that is?
Latin.
Latin? Anybody know what that means?
Repetition is the mother of learning.
Yeah, he Googled it.
I was watching the movie yesterday, and they were speaking Latin in the movie. Plus, I always heard it was repetition is the father of learning, but matter means mother in Latin.
That's right. So what does alma mater mean?
I'm assuming it means my mother's school. Yeah, I know that. I don't know chemistry, but I know that.
Maybe I'll put a Latin problem on there.
Oh, okay. Well, see how well I do on that.
Okay. So yes, that means repetition is the mother of learning. Okay, so the more you repeat it to you, the more it'll stick. Okay, it can also happen negatively if you see a negative habit. That can be built up as you repeat it. Okay, so be careful what you expose yourself to. Okay, so today we'll get into chapter 4. Okay, and in chapter 4, we're going to cover a multitude of different topics. Okay, and we'll really be getting into organic chemistry in this chapter. Okay, and one of the things we're going to study or get introduced to in this chapter is the whole thing of chemical reactions in organic chemistry. When we study reactions, we always want to study them under 3 headings. Okay, these are the 3 headings we want to study reactions under: thermodynamics, kinetics, and mechanism. Okay? When we have a reaction characterized under all 3 heads, then we will have it fully characterized. Okay? So what do these things mean? Okay? Thermodynamics, what it does is it looks at the energy of a reaction. It looks at the energy differences of a reaction. So as a reaction occurs, what happens to the energy of the molecules? Do they go up? Do they go down? What happens? And ultimately, when we look at thermodynamics, what we're looking at is if the reaction is favorable or unfavorable. Okay? So we'll wait till we get later in the chapter to unpack what that means. Okay? The second way we study reactions is kinetics. Okay? When we study kinetics, it comes from the Greek word kineo, which means rate, which means how fast is the reaction going. Does a reaction occur very fast, or does it go very slow? Okay? And that's what we want to study with that. Okay? If you know, like grass growing, that's a chemical reaction. It grows fast in the summer, and it grows very slow in the winter. Okay? So we want to study it from that perspective. The third way to look at a reaction is by way of mechanism. when we study the mechanism of a reaction, we look at the logic of electron flow. Okay? We look at the logic of how electrons are moving. Why do they move in a certain way that they do? Okay? Remember, we got introduced to the mechanisms where? In looking at acid-base chemistry. Okay? So if we can learn why electrons move the way they do, that will help us understand why molecules form the way they do. Okay? So the mechanism of a reaction is a good predictor indicator of a reaction. There's a lot of power in mechanisms, and we're going to cover a lot of mechanisms in this class, and especially when we get into 242. Okay? So, of the three, which one do you think we're going to start looking at first? Okay. Mechanisms. Okay. So let's start getting into that a little bit. Okay. The first kind of reaction we're going to look at are what are called free radical reactions. Free radical reactions. And before we get into those, we need to digress a little bit into another topic. Okay, so we'll come back to that. And the topic we want to look at first, before we get into free radical reactions, are different kinds of bond cleavages. Okay? Different kinds of bond cleavages. Okay? There are two kinds of bond cleavages. Let's look at the first type here. Let's suppose we had a hypothetical bond between A and B. Okay? What makes up that bond? Electrons. So let's put two electrons in there. Okay. Learn that from our Lewis structures. Okay. Well, one way this bond could cleave is if both of these electrons went to one particular atom. We'll just choose the B atom. Okay? So if we do what that arrow says, B would get both of those electrons. What kind of charge would build up on B then?
Negative.
Negative. And A would get a positive charge. Okay? This is always what happens with this kind of cleavage. Everybody remember the name of this cleavage from general chemistry? Okay, this was called heterolytic cleavage. Okay? The second kind of cleavage, let's draw that down here. Let's draw the same bond, A and B. And let's draw our electrons. What other way could that bond cleave? We could do a karate chop, okay? Where one electron goes with each atom. Okay? So if we do that,
Okay, I'll be right back.
the two atoms would split apart like that. Okay? So here, both atoms get the same number of electrons. The word for same is homo, so we call this homolytic cleavage. Okay? So what are the differences between homo and heterolytic cleavage? What's one difference?
Hetero, one gets both the electrons.
Okay, so hetero, one of the two atoms get both of the electrons. What's another difference?
They get charged.
Yeah, in heterolytic cleavage, I get charges, don't I? Down here, there's no charges. Okay? So, up here, I form ions. Ions are things that have charges. Down here, these are not ions. These are what are called radicals. Okay? So radicals are anything with a single electron on it. Okay? They're single and unpaired. That's what a radical is. And that's what we're going to get into in this chapter. Okay? So, heterolytic cleavage we're going to use this in polar reactions. Homolytic cleavage we're going to use this in free radical reactions. Okay? Polar reactions we'll cover later in chapter 6 and so on. Free radical reactions, when are we going to cover those? Right now. Okay? So we're going to get these out of the way, as we really don't use them much later on. Okay? Polar reactions are big. We use them throughout the rest of the book. Okay? So with this prelude done, let's come back to this heading here. Okay. So let's first of all look at a radical in more detail. Okay. So let's draw this molecule here. That we've become acquainted with. What's the name of that molecule? Methane. Okay. If you didn't know the name of that, I'd advise you to drop right now. I won't ask. Okay, so let's look at one of the bonds in methane, and let's do a homolytic cleavage on it. Okay? So let's break it in two. So if we do a homolytic cleavage, those two break apart from each other. And what do I need to put on that to make it complete?
Electrons.
An electron. Okay, so we'll put a juicy electron on each to make those radicals. Okay? Here you might call this what? A hydrogen radical. Okay? What might you call this thing over here? a, what's a CH3? Methyl, so call it a methyl radical. Okay? You could have a whole bunch of different kinds of radicals. For example, you might call that what? An ethyl radical. What might you call that? A propyl radical. What might you call that? Fishtail. Isopropyl radical. Okay? So be able to call radicals by their particular names. They're just regular alkyl groups. Okay? Let's come back to this methyl radical and look at it in a little bit more detail. Okay, so some review here. This carbon here, what's the hybridization of that carbon? sp3. Okay. We now want to figure out the hybridization of that carbon. Okay. Well, let's look at it in some detail. Okay. So that carbon has 3 bonds to hydrogen, like that. I now have to figure out where to put that extra electron. Okay? That extra electron is going to go in a p orbital, like that. What does that look like its hybridization is then? If I have a p orbital. sp2. Okay? So you can write it down. All radical sites are sp2 hybridized. They're sp2 hybridized. So what does that mean? That means that these 3 hydrogens are in the same plane. So it's flat. It's planar. So what did we learn here? That the radical has a top side, that is a top face, and a bottom face. Okay? And we'll use that later on in our radical chemistry. Okay? So there's a top face and a bottom face. Remember that electron is swimming back and forth in that p orbital. So it's equal on the top as well as the bottom. Okay? So this here is the first property of radicals, the hybridization. Let's look at a second property of radicals. The second property of radicals again, let's draw methane. If I counted the total number of electrons around the carbon, we would have a total of what? 8, which matches the octet rule. So methane is very happy to have 8 electrons. But what happens when we make the methyl radical? How many electrons does the carbon have now? 7. Okay, so here I'm missing 1 electron from the octet. So is this thing very happy here? No, it's angry. It's angry. Okay? If you're angry, you usually display it somehow. Okay? How do you think this thing is going to display its anger? What do you think it's trying to find? It wants another electron. And it wants it bad. It wants it right now. Okay? So it wants an electron. Okay? This is how cancer works in your body. Cancer is filled with radicals. And when it's in your body, it grabs an electron from wherever it wants to, whether it's your liver or whatever it's next to. And guess what happens to those organs? They deteriorate. And so it gets nasty. Okay? So you want to be careful of radicals. Okay? Radicals can get into your body in many ways. One of the ways is breathing the pollution from cars. You see the exhaust coming out. You're waiting at the stoplight and you're breathing that in. Not a good idea. Bad stuff gets in and starts circulating. Okay? There's other ways that radicals get into our bodies. We'll talk about it more later. We'll also look at ways to counteract the radicals once they get in your body. Okay? We'll talk about that later. Okay? So a lot of important medicines are developed to help counteract these things. Okay? But this is the main thing to take away of why it's reactive. It wants to get that extra electron to get the octet back. Okay? Let's look at 2 ways that it can get the octet back. Okay? So these are the 2 reactions of radicals that we want to master.
What was the name of that second property of radical? That's just what you call it?
It's called the reactivity.
Reactivity.
So what are some radical reactions? Okay, let's suppose we look at the first one. In the first one, let's take a methyl radical and let's react it with a molecule of ethane. What's going to happen? Okay? Well, this methyl radical wants an electron from here. So how's it going to take an electron? Well, let's focus in on one of the bonds. Okay. What it's going to do is take one of these electrons in the bond, and it'll take that outer one, and that inner one will stay with the carbon. Okay? So in other words, this radical is going to grab that hydrogen with its electron. And if it does so, what's it going to form? it'll form CH4. And then the ethane will convert to what? An ethyl radical. Okay? And this kind of reaction we call a hydrogen abstraction. Okay? Why is that? Because it's abstracting a hydrogen from another molecule. Okay? This is one way that radicals in your body attack you by taking hydrogens from different things in your body. Note that it forms a new radical. Write it down. It's forming a new radical. The initial radical is methyl, and I get a new radical, ethyl. See that? The electron, in a sense, has passed itself on to the new molecule. Or another word for passing it on is propagating.
Propagation first.
So we say that the radical has propagated itself, has passed it on. Okay? And this is the name of this reaction. We call this a propagation reaction. A propagation reaction, where I get a new radical forming. Okay? All right, let's look at the second kind of reaction radicals can do, besides the hydrogen abstraction. This time, let's bring two radicals together. Let's say a methyl and another methyl radical. How can these react? Here, these react by joining themselves together. It's saying, wow, I got 1 and 1, let's combine to make 2 to form a bond. That way we can both be happy. So this new carbon-carbon bond forms, and that's the end of the reaction. Okay? So we call this reaction a combination reaction. What's the main difference between a combination reaction and a hydrogen abstraction? Up here, I still have a radical on this side. Down here, there's no radical. The radical has been what? Terminated. Okay, so we say the radical has undergone a termination. It's been extinguished. It's no more. It's over. In the propagation, I still have a radical over here that can continue on and do some more reactions if it wanted to. It can continue to propagate itself. Okay? So these are the two main ways that radicals react that we're going to consider in the class. There's some other ways, but we'll just focus in on these two. Okay? And that's what we're going to use as we study these. Any questions on those? So I want to commit these to memory. Repeat. Repeat. Okay? All right. So let's see how we can start using them in a real radical reaction. Okay, let's look at this reaction here. Okay, this is going to be a radical reaction. Don't see any radicals there, but we will. We want to study how these products form. Okay. So we're taking methane plus Cl2 with H nu. What does H nu represent? Represents UV light. Okay, so anytime you see H nu, it's going to be representative of a radical reaction. You could have also have used delta. What does delta represent? Heat. Heat represents change too, but in this case, heat. Okay? So either heat or UV light can cause this thing to go. What we want to do is look at the mechanism of this. How does that form those products? Okay? That's what the mechanism does. Helps us to see how these things form by looking at the logic of electron flow. Okay? Well, this occurs in 3 steps. And the first step is called the initiation. Okay? First step of radical reactions is called the initiation. What do you think we're going to try to form in the initiation step? Radicals. I don't see any radicals there. So how can I get them started or initiated? Okay? What we do is we focus in on the weakest bond. And the weakest bond is always the halogen-halogen bond. Okay? So let's take that, focus in on the electrons. How's that going to break apart? Does it break apart on its own? No. We need some energy. That's where our UV light will come into play. That's going to give us energy to break it apart. It does the karate chop for us. So we can show the electron movement like that for our homolytic cleavage. And so that produces 2 chlorine radicals. Okay. Any questions on that initiation step? Okay. So we had to do that, but it's just a matter of which bond we broke. And we always choose the weakest link in the reaction. Okay. Let's go on to look at the second step. The second step is called the propagation step. Okay? In the propagation step, I'm going to propagate radicals. So what radical do I start with? The one I just formed. Cl dot. And what do you think Cl dot is going to react with? Yeah, I haven't used this thing, so let's bring it into play. So if I react with CH4, what kind of reaction do you think will happen here?
Abstraction.
A hydrogen abstraction. Very good.
So you have to write it out like that, you can't just write CH4. Did I interrupt you?
What's the question?
You can't just write CH4 for the propagation step?
You can do that. I'm
Okay.
just trying to show it in more detail. Okay? So here, the chlorine is taking hydrogen with its electron, and the other electron stays behind with the carbon. And so we get these two things here forming. You get HCl forming, which is what? One of the products. See that?
Okay.
And then I get the propagated radical, methyl radical forming. Okay. The methyl radical, is that a product? No. This is going to be what's called an intermediate, okay? That it just forms, and then we're going to see it disappears. But it's not a final product. We'll talk about intermediates more later on. Okay? So the propagation step, there turns out to be two steps involved with it. So we'll call this first step A. And let's go down here and look at the second step that we'll call B. Okay? In B, we will use the new radical we have formed, CH3 dot. Okay? And what do you think the methyl radical is going to react with? Okay? Well, this is where I need to give you a little help. Okay? This Cl2 only a fraction of those underwent the initiation reaction. Only a fraction of those. So I'm going to have some left over Cl2 that can react down here. Okay. So I'll have some leftover chlorine that can react with the methyl radical. So how will that methyl radical react with the chlorine here? It's going to act like what? A hydrogen abstraction. So this electron will come and grab one of the chlorines with its electron and leave the other electron with that chlorine. Okay. So let's draw the result of that. We would get those two things there. Cl dot would be the propagated radical that passed on from the methyl. And what is this thing here? It's another product. So here we have found out how both of these products form. Okay? And we have an intermediate. You think that's called an intermediate? No. Why is that not an intermediate?
Because it's not going to add a final product.
No. Why is that not an intermediate? Because that formed in the initiation step. Okay? So it's just being passed around. Okay, the intermediate, it is formed always in the first step of the propagation. Okay? So anything that's formed in the initiation step is not an intermediate. Okay? You need to memorize these two steps. How are we going to memorize? By repetition. Write these things over and over. Because you have to do it on the exam. Question?
You want, when doing on the exam, you want to do like initiation, propagate, just like that?
Right. Or I might just say, draw the propagation step for the reaction. Or I might just say, draw the initiation step. Or I might say, draw them all.
Okay.
Okay? Any other questions? Okay. All right, so again, today you have the option, if you want to take your quiz upstairs with George, okay, today, and get it over with, and review, or you can take it Wednesday, if you want to do that. The exam is on Wednesday between 3 and 5 in room 209, so be getting ready. And again, we'll have lecture in here, same time, same place on Wednesday. Okay? We'll see you then.
Are you saying yes?